image processing, data science. So I among other tools. So I love art. So I'm an artist and a co-member of the Good Art Data Science community and co-organizer there. So yes. So welcome to our today's agenda, which is Uttered Introduction to Data Science using R and beyond. So I've heard it said that the best way to learn a subject is to teach it. So I'm hoping that this will be useful for both sides, just me and you all together. So great. So let's see how we progress. So you have heard people say this a lot of times. Maybe sometimes it has become cliche that we are living in a world full of data, and more data. So we are in a place that we produce so much data and at the same time ingest so much data. So this goes beyond without any, how can I say, without any, no one can argue about this. But I don't want us to focus our attention on today's session on this. Rather, I know most of us here are students, so I want us to focus on this. Every field is producing data. So giving an example, like myself, I am taking electrical and electronics engineering. So we deal with a lot of IoT, Internet of Things, deploying sensors, which are taking readings and streaming data, after a while. Yeah, so that's my field. I'm producing data, yet I'm still doing engineering. So there's so many fields you can think about geospatial engineering, where they can be using data from satellite images, to track forestry, to do stuff like meteorology, prediction. That's a different field. So you could be a manager for a celebrity, and you're like, do people really like who I'm working for? So you can be doing stuff like sentiment analysis on Twitter, tweets or comments on social media. You are doing celebrity stuff, but you still need data. You could be doing astronomy, still need data. So we are in a place where every field, every student is in a discipline that is producing data. So that can ring a lot in our heads, like questions like, yes, I'm producing data. So how is data science involved in my field? So this goes to this. Okay. And then we ask ourselves, what's next? Yes, I'm doing electrical engineering, I'm producing data, but what next? So this is next, that we are no longer dealing with a specific field science. We're no longer dealing with electrical engineering. We're no longer dealing with geospatial engineering, not dealing with astronomy. We're no longer dealing with arts, sciences. This is what we're dealing with. So this is a video from our studio introduction, and to give us a better perspective.
We can't hear the audio.
Oh, sorry. Oh. And what about now?
Not really.
No,
you can.
Oh. Pardon?
Continue playing, we see if we can hear.
Yeah. Just a minute. What about now?
Not yet, not really.
Oh,
not yet.
Not.
Or you can stop sharing. Then when you share with audio.
Oh, great. Just a minute. Okay. Better, Bethany? Any
Still
good?
no, but you can share the link, then we'll watch it later.
Yeah, I'll share the link. So what the video was saying that it's no longer about a field science. We are dealing with data science. So we are in a time and domain where you are doing your discipline, but you're producing so much data, which is as important as your discipline, or more or less, but it's still vital. You need that data that you're producing. So you find you're doing a course, but the data you're producing really is doing much, is over, you overgo the course, and now you're dealing with data science. So this is where data science comes in our today's structure of education. So so what is data science coming to our context of today? So this is what I found like de facto what do I say, definition on the internet. I hope everyone else can read it. So, but in our session, we want to make things as easy as possible. So this is a good definition, covers all the aspects of data science, but let's put it in simple terms. Simply put, data science is an exciting discipline that
I can't hear you. I don't know the network or what.
Hello, we can't hear you.
Still can't hear you. Oh, well.
Hello?
You're back. Eric. Hello.
As we wait for his mic to, oh, it's back.
Back.
Hello? Hello?
Hi.
Hi.
I'm audible now?
Yes.
Yeah.
Yes.
Yeah.
Sorry. So sorry. I think internet is failing me or something. So can I continue, please?
Yeah, you can.
Okay, I'm so sorry. So sorry. So sorry. So I'll I'll start from here again. So simply put, data science is an exciting discipline that allows you to turn raw data into understanding, insight, and knowledge. So that's simple definition of data science. So we talked about data science being interdisciplinary. So we borrow a lot from mathematics, stuff like machine learning, statistics, to programming, having a tool to do the data science process, such as R, Python, MATLAB. Then there's a domain and knowledge skill. This is the course you do or the field of research you're interested in. Yeah, so that's one. And then lastly is communication and visualization. So you really, doesn't matter how well you do the data science if you cannot communicate your results with others. So this makes data science like a field that is trying to unify so many disciplines together, and that makes it exciting too. So we'll discuss about a typical data science project, which mostly all data science projects follow this, but doesn't have to. But a typical one looks like this, where we have data from the environment, such as sensors, images. Please mute your mic. And then to do the data science, you have to import the data. To import the data into ID, you have to tidy it, and then goes through a vicious cycle of data analysis. And then from there is what you have the most prized stuff, your insights, which you have to communicate with the rest of the world. So typically, most data science projects follow this cycle. So yes, so this is how typical, and we are going to discuss each in detail in our next slides. So we'll start with importing data. This is the norm. Taking data from maybe could be a file, a database, a web API, to the development to the ID you are using for data analysis. So this is just basically taking data where it is stored and putting it in your ID so that you can start the data science process. So for this, I tried to see some examples of people in our community who are doing some projects. So like this is, we have taken data, this is COVID-19 data. I've taken data from an Excel sheet and loaded it in my case to the RStudio ID. So basically importing data, taking where it is stored to your ID where you want to make further analysis. So from importing data, we go to tidying data. So we know this is the real world. Things don't go as planned, just like some few weeks ago. Our data is messy. So this is the point where we want to spend a lot of time. We want to make our data in a form that will permit us to do further analysis on it. So most of the case, tidying data involves putting our variables into rows, such as here you could see all the countries are put in under one column called country, and then there's a column called year, cases, population, and then making each observation a row. So just basically all, for instance, if you have data of counties, like in Kenya, you have Nairobi, Mombasa, Nyeri. So you don't want them to be each in an independent column. You want them to be in one column called, counties. So one basic way of tidying data. So tidying data could be also, removing not available values, missing values. You get a lot of that in the real world. So there are places where they're missing values. So you want to clean that up, maybe replace it with a mean or something. So tidying data could be also putting variables in the correct format. For instance, a date value could be being read by the ID as a character, but want it as a date. So converting, characters to dates or something to the appropriate format that's tidying data. So basically, taking the data, putting it in a form where can easily enable us to do further analysis. Then after tidying data, we have an example. This example of tidying data. So as you can see on the image on the left, that was the data set I shared before. Each date had an X. Each date with an X had its own column, but we don't want that. We want each date to be under one column called date. So as you can see on the right, this is a bit more tidy data. So yeah, that's one of the processes of a simple illustration of the tidying data process. So can be a lot of stuff, but those just basics of tidying data. So after we have a good, nice tidying data set, we want to transform the data. So what does transforming data involve? Could be narrowing on observation of interests. For instance, you have a data set of all the countries in the world. You want to just narrow down to Kenya. That's transforming the data. You're just filtering the data set based on the country, a specific country like Kenya. Could be creating new variables. You could have a data set that has distance and the time taken, and you want to create a new variable, say speed. Speed is distance over time. So you create a new variable called speed, which relies on the existing variables in the data set. So a way of transforming data. And transforming data could be, calculating summary statistics. This includes stuff like mean, count, and exactly just summary statistics from the other variables in the data set. So that's another way of transforming data. So these are some of the major processes involved in transforming data. Of course, there are others, but I decided to narrow down on these main ones. So after you get a tidy data, you just have to transform it do some of these steps and have a data set that you are really trying to, that will help you answer your questions in a really better way. So transforming data and data rank and data tidying take up a lot of time in the data science process, and they are most referred to as data wrangling. It feels like you're really fighting with the data. So that's it. So the two most essential parts in our data science process, in my opinion, that is. So a good example could be like this, where we can see maybe in the left image, we decided to narrow down on our country, Kenya. So just narrow down on a specific country. That's narrowing on variables of interest, a form of transformation. On the left, you can see on the right, you can see we decided to maybe narrow down on Africa as a whole, did some summary, put all the confirmed, the recovered cases in each column. So yeah, so that's a really good example of transforming data. You have the variables already and you create new variables from the existing ones to help you answer questions that really intrigue you. So going down from data,
There's a
hello.
hi. There's an echo coming from your end.
Can also coming from my side. Hello. Hello.
Hi.
Hello. So better now? Hello. Bethany?
Hello, yes.
Hello, Bethany.
Yes, you can hear.
Is it how is it?
There's a loud sound like keep
Still on the sound?
yes.
Better now?
No,
Is it
it's now better.
it's now better?
Yeah.
So Hello?
Hello.
Hello?
You're still echoing.
Oh, still echoing. Just a minute. Just a minute. I, 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 I I come to the meeting again. Oh man, what is happening?
Okay, as we wait for Eric to come back online.
Bethany, I'm here.
Oh,
So is the sound better, please?
it sounds better.
I'm so sorry. I don't know what's happening. So yeah, sorry. So so we were on visualization. I'm so sorry for that. Oh my God. So visualization. So we are at a point where we want to do some exploratory data analysis. Want to see
Can you
how
share your
this.
screen?
Oh, yeah, should be locked and loaded now.
Yeah. Thank you.
Great. So we are at data visualization now. So after tidying data, doing some summaries and creating new variables, we are at a point where we want to see how one variable is related to the other. And this is where visualization comes in. So you may have heard this quote: "The simple graph has brought more information to the data analyst's mind than any other device." So it's a quote by John Turkey. So at a glance, you want to see, for instance, is variable X contributing to variable Y? Does putting more milk in chocolate bars, does it make customers more happy, or having higher percentage of cocoa in our chocolate does make customers more happy? So this is why I want to see how our variables are affecting what you want to predict. So a good visualization is really invaluable. It shows you stuff like things you didn't expect. So it could surprise you. This is this you think maybe variable X and variable Y are related linearly, but when you graph it, you are like, oh no, it's nonlinear or polynomial. So it shows you things that you totally didn't expect, which can be good or bad, and helps raise new questions about the data. So seeing how one variable is related to another can help you, you know, ask the question why. Why is this decreasing? This is increasing. Why is what I thought will happen not happening? So helps raise new questions about the data and can make you go back, rethink your questions, and try to gather new data or something. Yeah, so visualization is a really essential part when you want to do some data exploration. So with visualizations, you are, how can I say, you are spoiled for choice. There are so many tools out there that can help you make masterpiece presentations or masterpiece visualizations. And there's so many types of, how can I say, visualizations or graphs that can help you see trends in data or relationships in data or gather insights from data. So could be box plots, could be line graphs, could be pointer, how can I say, how do you call them? Could be, there's so many bar plots, histograms, there's so many. You could also want to put some action on the figures, like animate your visualization. All that, if it helps you, have a good picture of how your data is related to one another, perfect, go for it. So the people who are doing this decided, maybe for instance, this is decided to animate the data, maybe cumulative number of cases with the date that happened, for the data set I was doing. So great. You can use this to know maybe when did people start recovering and all. So good visualization essential. So keep that in mind. And then after we have visualized the data, we have known this is relating to this. This variable can help me answer the question, answer my question better. You go to the process of modeling the data. So data modeling is, how can I say, is complementary to data visualization, because data visualization, you are seeing, yes, this is decreasing, but this is decreasing, or this is increasing, or this has a polynomial relationship with this. But when you get down to the modeling of data, you are getting the numbers, the real numbers, to what extent is this related to this. So there's so many models you can have, of so many algorithms. For instance, in our picture here, we have a STAN, we have a Keras, we have a linear regression model algorithm, but at their core, they are fundamentally mathematical tools. So these are just formulas relating variables. And there can be different types of models. For instance, we have predictive models, which go by the name, which from their name show that you're predicting stuff, and data discovery models, which really help you understand hidden relationships in your data. So predictive models, predict data discovery models help you see things that cannot be really seen by the human eye or something. So in other, for people who have been in the field, they call them supervised and unsupervised learning. So different types of models. So all of this essentially come down to one simple fact. Can we make predictions or make results using the data we input? So when modeling data, you find yourself that you cannot escape this phenomenon known as machine learning. So in this part, we'll try to really try and demystify a few points about machine learning and all. So, and let's just take a step back and about the fundamental question. Could a computer go beyond what you know, how to order it to perform, and learn on its own how to perform a specified task? So this question essentially is, like the birth of machine learning. Can a computer like give us results without us exclusively programming it? So great. So this is where machine learning comes in the data science structure. So with machine learning, I really wanted to bring this out. I hope when I was starting out, I could find 2 articles about machine learning. So there's an article where they do so many big formulas, and they end with, as you can see, this is obvious, and you're like, I really have no idea what you've said. Then there's some also like this, how can I say, bloggers just writing fishy stuff, how machine learning will like come kill us everyone. So sometimes it really blows up your mind. What really is machine learning? And you're left wondering if the truth is in between or in either. But that was just a sidebar. So machine learning, simply put, is a field of study that gives computers the ability to learn without being explicitly programmed. So the term learning and explicitly programmed narrow down to one simple thing, that the machine figures out the model out of the data. So you just have to give it data and an algorithm, which is a method used to process data to extract patterns, and figures out the model, figures out the relationship between the variables, different variables you're trying to predict on its own, and gives you a model. So data and algorithm figures out a model, and from that model, you can put in new data to try and make predictions or results. So this I tried also. I found a really simple explanation of how to go about machine learning. So here's a problem that we're trying to separate the blue dots and the green dots, and we have put in our data. We have put in an algorithm. As we have said, algorithm is a method used to find, the patterns between data. So an algorithm such as logistic regression, for instance, and so after giving those inputs, we can see that the machine is trying to, really learn by itself which point, which slope give me the best distinction between the blue and the green dots. So that is really the magic of machine learning. Give it data, give it an algorithm, and boom, tries to figure out a model, how the variables are relating to each other, and that can be used to, predict future instances, future instances and answer future questions. So yeah, so that is machine learning. And having a high level overview of machine learning is just a repetition. You get data plus an algorithm, get a model, put in maybe a training set or input data, get an output, try and verify if this is really correct, and if not, maybe try to change some parameters and all. But for beginners, this will be learning in our course. We have a course on machine learning, so coming soon, so we'll cover this in more details. But for high level overview, this is what happens. So, guess what? We use some of these concepts every day. So we'll try to explain classical machine learning using some of the things we do every day, such as clothing. So as you said, machine learning is divided into supervised and unsupervised learning. And so for supervised learning, you get classification, where you predict a category, and regression, where you are predicting a number. So a simple explanation of trying to predict a category is how you divide your socks by color. So, I have socks. So my socks are either blue or yellow. No, are either bad colors, are either black, white. So trying to divide them by color, that's a good example of classification. So color black goes this, color yellow goes the other way. So classification. So some type of try to understand regression. Maybe we're trying to predict a number. So what if we divide our ties by length? So yeah, so our ties will be divided by their length, maybe in centimeters. From this one, this is a short one, this is a long one. So that is a good example of regression using our day-to-day lives. So for unsupervised learning, we are trying to figure out the underlying relationships between our data. For instance, let's say clustering. You are given a lot of clothes in your closet and divide them into, these are jumpers, these are pants, these are shirts. So an example, that's clustering. You divide by similarity. So you can also identify sequences using stuff like association, right? Like, what clothes do I often wear? You see, that's simple example of unsupervised learning. This is really useful maybe in social sciences. Maybe you can want to find who does Eric talk to most, who does maybe Bethany talk to most, who does Ryan talk to most, who does she associate with most, so that identifying sequences in data using unsupervised learning. Then lastly, for supervised learning, class machine learning, we have generalization. We try to make the best outputs from our given data set. So maybe you have clothes and you're like, if I match this and this and this, I will make a killer pose and killer entrance. So that's really simple example of generalization in machine learning. So machine learning is quite an essential part in the data science process, but for you to get good results, you have to have good data. So that's why we emphasize on spending a lot of time in tidying your data, getting good data in the first place, so that your machine learning algorithm can also predict good results. So sorry, this is not playing. I don't know why. We tried playing the initial video didn't play, but just a sidebar, or why is intelligence only linked to human? So this is a project where they're trying to train an avatar, like a real avatar. This is not a movie or some research going on. So I will share the links. I will share my slides and the links to this. So sorry we could not play this, but yeah. So what just trying to emphasize is if you have good data, if you have good examples, you will make a really good model for predicting future results. So the better your data, the more you expose your model to data, the better the results you're likely to get. So some of the coming down to our last part of the data science process is communication. So you have tidy data, you have masterpiece visualizations, you have accurate models, you have world-changing insights. But one question is still left. Can you communicate your results to others? So this is a really essential, also a core essential part in the data science process. You have done everything, but can you really communicate your understanding of the data or of the questions you have asked and able to answer well with others? So, as you can see from this little picture, you can see why the visualization on the most left got the job, because the visualization is really speaking out on itself. So this cannot emphasize more that it doesn't matter how great your analysis is unless you can explain it to others. So not only in visualization, but maybe in the way you write code, in the way you comment, can it trigger collaboration with other data scientists? Can it explain it to your future self? Maybe you're coming back. Can you know what exactly was I doing? Yeah, so communication is really quite an essential part in the whole data science process. So we can do data science with programming or without programming, but in my case, let me just take away to speak about programming. So in all the stages that we mentioned, from importing to communication, we use programming. So can be quite a tough, but it's essential. It's essential. I mean, it's really essential in our day-to-day activities in the data science process. And so maybe speaking from my part, I used to struggle a lot. We all struggle a lot sometimes. But there's this quote by Hadley Wickham from the book Art for Data Science by Hadley Wickham, says, you don't need to be an expert programmer to be a data scientist. Yeah, so, but learning programming, being a good programmer helps you automate tasks a lot. So makes your work easier. So you don't need to be an expert programmer to be a data scientist, but it pays off in the long run. So this is if you feel I don't know programming, I'm not a good programmer from a background that you do coding, but So these languages are built in a way that you can learn by yourself. You can that you really don't have to be from a programming background to do data science. This you can start up, just dive in and see, boom, you can reach that level of being a data scientist without having to be exclusively from a programming background. So doesn't really matter the language. Could be R, could be Python, could be MATLAB, could be SAS, but what matters is, can you do the task using this language? So don't really focus on this language better than the other. Most languages are just trade-offs of one another. So just try to see which one you love and just dive in. My advice. Yeah. So just wrapping up. We have this one quote that data scientists are changing the world. From genomics, from medicine, from engineering. As you said, it's no longer field science, it's data science. And data scientists are really changing the world. Like, there's so many cool things being done out there by data scientists. So it's only our hope that we can change the world too. So I believe we can change the world too if we, wrap up these skills, try and learn as much as we can, and teach others, share others. We learn by teaching. So yeah, so that marks the end of my presentation. So so first, apologizing so much on the initial hiccups. I don't know if it's Teams or it's me, but whoever, I'm so sorry. But yes, so that was what I had for an introduction to data science. So before we end, we'll have Ryan. Ryan, are you there?
Yes.
Hello?
So I will be taking you through. Okay, can you give me 5 minutes? I need to
Okay.
relocate to somewhere with electricity.
So before things get wrapping up, so I could take a question or two before Ryan prepares. So this was supposed to be the introduction to the science and a little thing about the art language. So yeah, so anyone, I could take any questions if there are, please. Bethany, are you there?
Hello.
Hello.
Hello, Eric. My name is Selena. I have a question.
Yeah. Hello, Selena.
For those who are not in a technical course or even in an engineering course, what do you think is a skill they can teach themselves before they venture into data science or data analytics?
Oh, great. So first things first, as we said, anyone can do data science regardless of their background. So my advice to you could be just dive in. I know it sounds so absurd, but you could start by, okay, let me see how I did. So do you know something like Microsoft BI or Tableau or something? It's a great visualization tool for pick and place. So you can go check it out. So that really helped me in my initial days for like, this is data science. These are the questions that I should ask. But it's really not essential, in my opinion. So if you're from a non-technical background, it's still possible. You just have to find a language you love. It could be R, it could be Python, it could be the ones mostly used for data science. So find one that you feel, I think I love this, and get help online, get help on Twitter, and just start. So that would be my advice. But don't really stay on the opinion. I'm not from a data science. I'm not from a programming background. I'm not from engineering background. So out there, everyone is doing data science regardless of their course. So I hope I've answered your question, Selena.
Thank you. You have. And can I ask one more?
Yeah. True. Sure.
What is the difference between data science and data analytics? I don't know if you tackled that at the beginning, but I came in a bit later.
Oh, great. So, data analytics. Data analytics. How can I say? Is part of the, data analytics. We're trying to see how one variable is related to the other. Like how are my sales related to this part of the world? How the sales in Africa? How are the sales in North America? The sales, in Italy. So we're trying to really find. We have a question, and how is it being influenced by other factors such as region, demographics. So that is data analytics. So, but you see, with it's a part of data science. In my opinion, it's a part of data science because data science involves a lot of visualization, and data analytics also involve a lot of visualization. But data science tends to go further. Like we are like trying to see, I have this historical data, but can I go a step further and see if I can project some variables? Can I project my sales in the next 10 years? Can I see the air quality index for the next 2 months? How long will this COVID pandemic last? Something. So it's an extension of the data. So data science is an extension of analytics. It's something, data analytics, something inside data science. Yes. So hope I've answered it.
Yes, thank you.
Yes. Okay. Welcome. So, any more question?
There's someone in the chat asking if you would mind sharing links to sites to get more resources on ML.
Great. Yeah, I'll be sharing my slides. There's so much for the video that we had, but I will share my slides, and I'll add up links to where you can get help. So I will do that. Definitely do that. Thank you, Bethany. So anyone with any other question? Okay, so Ryan.
So hi.
Hi.
Sorry for that. I was moving to a place with electricity. Okay, because we had a critical failure from this end. So my name is Ryan.
You share your screen.
It's not displaying.
It's okay. It's okay.
Screen. Okay. Okay. So my name is Ryan, as an enthusiast, and a member of the Coot R team. So today I'll be covering introduction to R in general, why you should consider it as a language, and facts about it, I think. Okay. I am so So, first off, you have to ask, and Sorry for that. My
Hello.
net just went off.
We're losing you.
Hello.
Hello, we're losing you.
Can you hear me better? Or should I just?
Yes, we can hear you better.
So, first question, what we were trying to bait you into the topic was an introduction to data science and an introduction to R, which is one of the languages that you can use to process the over on this end. So, first question is, what was R? So R, just like its oddly named friends like MATLAB, Python, C, Java, the coffee, but Java is a programming language, right? By definition, R is a programming language used for statistical computing and graphing. What this says, in very many fancy words, is that R is a language that you can use to analyze your data. And once you've analyzed your data, you can use it to present your data in a form that will be attractive to the eye, one, and two, that will be able to infer things from the graphs or the models developed. So you can use the language to develop the statistics. You can use it to develop statistical software, which was mentioned earlier, or analyze, as I've said before, analyze your data with a very wide variety of tools and packages. For example, I could decide that like this graph was a box plot on the standard deviation in the climate in Berkeley from the 1900s. Or there's this graph that shows the quantity, you had nothing, cut and clarity of a shipment of diamonds. As you can see, you have very many colors. As you can see, you have very many colors. It looks appealing to the eye, and you can easily see what you need from the graphs. Last of all, this line graph showing the life expectancy in East Africa minus Burundi from 1950 to 2000. So as you can see, okay, I haven't shown you, but you can do a lot of with R. So why should I pick R? Because there are very many programming languages. You have MATLAB, you can do it with Python. There's this Mandalorian that kind of looks like the Mandalorian. There's Orange, there's SciPy, there's Analytica. All these are both free and paid. But why pick R? Because first off, R is very easy to pick up. It doesn't matter if you're in business, if you're in finance, if you're in food science. No matter how little or how much programming language you have, knowledge you have, from either zero or you could be a Python expert who's coming in to learn R. But it's very easy to learn and to pick up regardless of your profession or age. Second, with R, you can easily create well-designed publication-worthy plots, the mathematical symbols and the formulae. And also with additional packages, you can also get dynamic and interactive graphs. As you remember from Eric's presentation, you saw that there was a graph showing the COVID-19 cases that you could see it was beautifully animated. This is also a graph that he did done for a course that we'll be taking you through later on. It was beautifully animated, and you can do this for your website. You can decide that you're going to publish these beautiful graphs, and you can do it easily within R, or it could be for a slideshow like this. Third, you can easily modify it for use in your target field. For example, if I'm in finance, I could decide, oh wow, I need to build a model to analyze my customers, or maybe I'm I'm a celebrity. I use ticket sales, and then I analyze, I find my target audience. Maybe, for example, for One Direction, they'd probably be targeting what women in roughly their teens and their 20s. And they can easily do this using R. And bad quality, network quality. These packages, like there's this shiny, can you hear me? There's this shiny, there's tidy, there's TensorFlow. There are very many packages that can allow you to modify what you need. Set up to what you need. So, and as I've mentioned above and on, from these really complex ones. Can you hear me better?
Hello, Ryan.
Yes. Can you hear me better? I moved location.
A bit. Hello. Yeah, that's better.
Okay. So, as mentioned, R is ridiculously flexible. From statistical models to web applications and HTML slideshows, R has your back. You can even create a website using R Markdown, which is one of the packages that I see here. Okay, then it's very popular. And if you are looking at that angle, it's also getting very popular with employers these days. This popularity means that there are a lot of events that you can attend. There's a large supportive community, and there are a lot of free resources online. So you'll find, if you're new to R, if you're old to R, regardless of experience, you can find yourself looking, you can find help on Stack Exchange, you can find help on blogs. We have contributors who create these wonderful packages and provide them for free. And so I'll be showing you some of the few R users that you can find, that you hear a lot of people talking about. So guys, then there's you with your fancy sounding title and your own website, hopefully in the future. Who knows? Maybe you'll be the one who's giving this, you'll be the one who's teaching us something new in a month or two. R can also handle complex and large data. We have the complex simulation and supports multi-core task distribution. As you've heard Eric talk about it, you've heard Eric talk about machine learning. So it's possible for you to create models. It's possible for you to create your models and train them using R. And then this one's mostly for advanced users. I'm not quite there yet. I'm not even close to being there yet. But you can link code in C, C++, and Fortran, or you can write code in other languages and use it to manipulate R objects directly. So, who uses R? Everyone can use R, but you'll most likely find scientists using it to do their epic science plots. We have data miners. So as you probably know this, you'll hear people saying, what is, this is data mining, data mining, data mining. So, although So data mining is the process of gaining information about like your user and using it to optimize, let's say, a service or an experience, so to speak. So you can use R to analyze the data that you're going, hopefully legal sites and and come up with plots and graphs to how they're responding to a certain let's say a certain ad. For example, Google. I'll be taking data about you and several other users. I analyze what time you probably want to see certain ads and which ads you're more likely to respond to. I can analyze that using R. So statisticians also can use R. It's very easy to find. You get your data, you find the mean, the mode, regression curves. When you decide you just want to find the median using R, that's what I'm good. Then people tracking their budget. So there's this show I was watching called Extreme Couponing, and I found that it would be really easy. I thought that it would be really easy if those guys, instead of creating a spreadsheet each and every time they needed to go shopping or doing something, because you have to go online to check your sales, blah 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 blah. They could have easily done the data analysis in R, and they'd be able to know exactly how much they've spent throughout the years, how much they've saved, and which stores would most likely give them a nice discount. Then engineers, as anyone generally, you come into contact with a lot of data, like data from your sensors, data from previous experiments. So you need to, when you collect this data, you need to use it, you need to analyze it so that you can come up with, let's say you're developing something new. For example, I am developing a timed switch so that you don't have to keep waking up and closing the door. Like once you not closing the door, like shutting something down when you're not in. So I can decide I could create a prototype, I give it to many people, and then I insert a GSM module and collect data and see whether people like it or they don't. Researchers, like for example, the people who are doing the COVID-19, right now they'll get, I'll get, let's say, I can decide to use to analyze the response of the virus to certain reagents. Or I could just decide to analyze the amount of tests that a machine can do within an hour. Auditors can also use R. Accountants, just anyone can use R. So as you can see, all these companies use R to analyze their data. So as you can see, we have Facebook over there, Google, IBM, all of these are very, very large companies. And they're all using R to analyze their data for optimal sales, let's be honest. And also for the best functioning. To cut the long story short, anyone, and I mean absolutely anyone, regardless of programming experience, age, profession, etc., can use R. From everything from ranking your most watched shows to predicting the current pandemic curve, R has you covered. So that's what I've prepared. Any questions? Am I then broadcasting? Am I still on?
Ryan?
Yeah, I'm still here. So, any questions?
Maybe for someone who wants to use what ID can they use?
Pardon?
Maybe someone wants to use R. What IDE can they use?
Oh, for R, let me just get there. For R, the IDE, the most popular IDE would be R Studio, which you can get from their website. It's free, and also the packages, which you can download from there's a current repository, or you can get them from GitHub. You can download also the packages from there. And what else? Yeah, but R Studio is the most popular one. It's open source, you can get it very easily.
Oh, and someone asked, what is the best platform to learn R?
Okay, the best platform to learn R. You can, okay, we're going to be having an introductory R course during the course of this month, next month. So you can tune in for lessons there. But there's this really cool, this website I saw that had really nice tutorial called Analytics Media. And you can also get, there are also tutorials on the R Studio site. There are also video tutorials on the R Studio website. There are also books, cheat sheets if you forgot, if you forgetting about stuff like me, yeah. You can also follow, there are very many art users on Twitter. They're very welcoming, and you can ask them questions and they'll respond. Like Exchange is also a good place. Yeah, you just need to dive in. You're going to think it's difficult at first, but it's not. Surprisingly nice.
Okay, so thank you, Ryan. Yeah, so another good place to learn R is the R for Data Science book by Hadley Wickham. Please check it out. And as Ryan said, the Twitter community is really welcoming. So much stuff that happen in R takes place on Twitter. So just log in, follow these guys, and trust me, you'll learn a lot. Yeah, so just to add on what Ryan has said. Yeah. So maybe anyone with any other question?
The R for Data Science book can be downloaded from the R Studio website if you're curious about it.
Yeah, so that's Ryan. I hope you'll share your materials too. Maybe add.
Yeah.
Okay.
Oh, the power's gone again.
Okay. So maybe anyone with any other question? I think we have come to the end of our meeting. Anyone with any other question, please? So Bethany, could you talk about the upcoming AI session, please? Maybe for a minute or so.
Okay, hi guys. So we'll be having our Python sessions every Tuesday at 7:30 p.m. So this coming Tuesday we'll be doing an introduction to Azure, AI in Azure, focusing on Azure Cognitive Services. Then from there, for the next, after this week, so the next 3 weeks, we'll be having sessions, hands-on technical sessions on Python and data science. For example, the first week will be scraping data from Twitter. And then the next week we'll be cleaning the data we scraped from Twitter. And the last week we'll be building a bot from the data we scraped from Twitter. So it will be like a series on Python, hands-on Python for data science. So yeah, then in May, I am hoping we'll be doing more machine learning and in Python, and we get guests from Microsoft and other companies, people who are in the industry, to come and talk to us about the experience and what you need to know. And yeah, they can even hold technical sessions. So if you have any person in mind you want to see, or if you have a session in mind that you want us to hold, you can inbox. Yeah, you can inbox me or email me. My email is bethany@studentpartner.com. Yeah, I think that's all.
Yeah, so thank you so much, Bethany. So maybe we should also say something as we end about our staffing R. So this was just an introduction to everything. We hope to do maybe starting from next week, starting with basics in R, getting right in syntax, and then we go on to visualizations using ggplot. Then we do some data wrangling with deployer and all. So we want to work on the COVID-19 data, hopefully. Yeah, so that's our plan. And on 30th, we are having a session with Shell with Karaoke from the slides of Ryan. She's a data scientist in Africa R. Maybe some people from Microsoft are open. By the way, Microsoft has an R part in their structure. We call Microsoft R open. So we hope we'll be also interacting with those people. So Bethany and I, we have so much for everyone, both in R and both in Python. So we really hope you can come in, any questions, and we can do quite a lot of stuff. We can like change the world or something. Yeah, so I want to leave it at there. If please, let's join in for maybe next session. The cognitive services by Bethany looks very exciting. So I hope to see you there. I'll see you there, Bethany. I hope all of us can come in. And yeah, I want to leave it there. If no one else has a question, I think we will end it up there.